All right, good morning, everybody. Uh, Today is the second day and the first day for the MMSys main conference research track. I am really excited to have our second keynote speaker today with us, Kathleen. She flew all the way from San Francisco. She might be the person who flew the most for this conference, actually, given that most of us, based from this region, Europe and so on. And really appreciated Kathleen for that. So Kathleen heads up the hardware team for Facebook Reality Labs, and this is obviously not a very remote topic to this community. So there have been a lot of VR papers in the last several years. So a lot of you have been working on either on the encoding side or the streaming side or the user experience side. So I think we will really appreciate what Kathleen has to say today. Um, Apparently, she has done a lot of design for all the hardware gears we use in our demos, and so if you have any problem, that's the person to blame. So all the Oculus series and the Rift series, right, Kathleen? And then I'm sure she will also tell us, some of the things maybe in the pipeline or things that they are working on, and the technology behind it. She is a mechanical engineer by education, by the way. I mean, that's really interesting, right? Probably that's the she's the only mechanical engineer in this room. I expect. So everybody else probably will be just a computer science or electrical engineer here. She got her degree from Stanford University, 2007, and then she worked at Apple, now Facebook, and we are really again very excited to have you here. So thank you. Stage is.
Thank you.
You can ask questions in the room, or obviously the panel for the Q&A on our website. So I'll forward my questions to you.
That sounds fine. Hey, everybody. It's such an honor to be here today. And I'm excited to be the only mechanical engineer in the room because whatever I say, you may not know if I'm right or wrong. So that's nice. Just kidding. But it is my first time in Istanbul, and you just have an incredibly beautiful city. So thank you, Ellie, for having me. Thanks, MMSys and the tech folks for getting us set up. So I'm going to talk about VR. But first, I'm going to introduce myself a little bit. Because when I was 5 years old, my parents bought me a very fancy, very expensive for us little remote control car. And I'd been asking for this remote control car for weeks and weeks and weeks, and they finally gave it to me for Christmas. And as soon as I opened it, I promptly took it apart. My parents were so confused, but I wanted to see how it worked. Like so many engineers, we like to tinker and take things apart. And I just hadn't quite gotten to the point where I knew how to put it together again, which came much later. So they were so upset. They promised never to buy me another remote control car. But eventually I wore them down. And a few years later, they bought me this Batman race car, which was very exciting. It was beautiful. It had working lights. It was really fast. It had a cockpit that opened and closed. It is the exact car. I found it on the internet. It's a 1986 car from the Batman movie that had just come out that year. So I looked for about 2 days to find it, but it is the exact car. Not the exact one I took apart, though. So they bought me this Batman race car, and I waited a painstaking 5 days before I took this apart. And I just couldn't help myself. I still can't help myself. I'm addicted to hardware. I need to touch and feel things with my hands. So today, I'm the head of VR hardware for Facebook Reality Labs, a division at Facebook making hardware products that connect people. And now we actually are much bigger. We have four divisions, 4 product classes, but we only had one to start out, and this was the first. So my job is really to work on the hardware that takes what you all do and makes it a reality. So of course, Facebook is a software company. So this is exciting because it was their first foray into hardware. And so we started with the Oculus Rift, and then the Oculus Go, the Quest, the Quest and the Rift S that same year, and then the Quest 2, which just came out in the fall. How many of you in the audience have tried VR before? Almost everybody. That's great. Okay. So I didn't take this job at Oculus because I loved VR. This was really early, and at the time, I thought that VR was only going to be for people who wanted to play video games. And I like video games, but that wasn't going to be interesting enough. But when I tried the prototype, it was called a Crescent Bay prototype. I first tried it, and I was actually on the edge in VR of a building, and I got like vertigo. I felt like I might fall, and that's when I knew something interesting was happening. I started to feel presence, the sense I was somewhere else, and that's when I got hooked on VR, and I realized this is really going to be a big part of the future. And so it was an opportunity to do something and make something that had never really been made before successfully. Now, as a young engineer, when I was at Stanford, I actually struggled. I had a hard time in engineering school. I was really privileged to be at Stanford, and I'm really glad that I went. But engineering school was mostly about working on problems that other people had already solved. And I wanted to solve new problems, and that's what I was passionate about. So all the fun that I had was either in my internships in summer, or it was the machine shop. And this is actually going to be a video of our machine shop at work. But when I was at school, it was the machine shop that kept me sane. I liked the way it smelled and the cutter fluid, the aluminum shavings everywhere, making things with my hands. I was happiest there, and I really liked learning practical skills. Again, I wanted to solve problems that nobody had ever solved before, which is actually what this community is all about. So this is a little bit about what our labs look like at Facebook Reality Labs now, and how we make these products. So I've learned some things in my career making new products. And I hope that the things that I've learned and I'm going to share with you are just as applicable actually to what you're doing as they would be to a mechanical engineer. So there are some principles that I want to share with you. And the principles are really about going from 0 to 1, making new things or making things with really big parts that are new. And I would imagine actually that the future of VR is going to require some really creative solutions in streaming and in coding. And so I'm really, really excited, hopefully, to talk to some of you about that and how we're going to do that in the future. Today, though, I'm going to share these few rules about making great products that customers are also going to hopefully really respond to. So I'm going to combine these product development rules with the fundamental things I've learned about making VR great at Oculus. And so the first rule is define your non-negotiables, so that the first time you set out to do anything, I think this is probably the most important thing that we do. And a lot of times we don't do it at all because it's so exciting to just jump in and start coding or start making things. But actually, I think taking a break, a pause, and saying, okay, what am I doing this for? And what do I hope to get out of it? And is there something that could happen where I wouldn't ship this thing to a customer if it wasn't good enough? Those are your non-negotiables. And so we're going to talk a little bit about VR. Before last year, before 2020, Oculus had just 3 headsets in the market, and they were really different. 3 very different headsets. They had different optics and displays. They had different ergonomics. They had a lot of different decisions about how we made them. And so I'm going to talk about how do we decide. The first thing is we had to figure out who each headset was for and let everything else follow. So for example, Oculus Go. Does anybody remember this? And it was ages ago in VR. It was 2017, which is funny because so much has changed since then. This was actually the first all-in-one, meaning you don't need a PC or a phone, mass market VR headset. And we were willing to make a big trade-off with this headset. Folks know 3 DoF versus 6 DoF, right? 3 degrees of freedom, this 6 degrees of freedom, I get to walk around and move around like this, right? So big difference. But we were willing to ship this with 3 degrees of freedom because we wanted more people to try VR. And some people, it was their first experience trying VR, actually. Was that your first experience? Oh, yeah. And that's what, because it was $199 in the US dollars. And this is what we wanted to do with this product. We want to get VR to as many people as possible. And because we actually envisioned this device as something that people would use to watch multimedia, to watch Netflix, to watch videos. So 3DOF was good enough. And we made sure that the battery life was long enough that you could watch an average full movie without having to take it off. I remember actually I wore it on a flight once, and I think the flight attendants thought that I was crazy. But what I didn't realize is when the plane would start to turn, everything I was looking at would start going like this. It was pretty funny. So anyway, our design targets included battery life and wearability for the ergonomics for the length of a movie. So in order to hit our targets, we had to make the headset as comfortable, as light as possible, reduce as many parts as possible, because not having wires or a phone that snapped into the product sharpened our focus. For the first Oculus Quest and the Rift S, we had totally different goals. We actually wanted to bring an immersive 6 degrees of freedom experience, at least with the Quest, to mobile. So it was actually the first mass market 6 degrees of freedom headset. Didn't require a phone, didn't require a PC, which meant all the processing had to happen on the headset itself. And to be truly mobile, we couldn't have an external sensor. You guys remember the first Rift had a sensor that you put on your desk and faces the headset. And sometimes you'd need more than one. Well, this thing didn't need any of that. And so when you gave it to a customer, if they didn't know, I mean, I don't know if you guys remember, but the first VR headsets, they were amazing, but there were all those cables everywhere and all these parts. But this thing was just one, take it out of the box, put it on, it just works. So this was a radical departure from how we made the Rift, and that was our priority, is to make it easy. So anybody could put it on and it would just work. So we boosted the battery life as well and maintained the comfort and ergonomics. And fast forward to now. This Quest 2 is our flagship product. It's our latest and greatest VR headset. And it hangs on to the features that made the Quest 1 great. It's easy to use out of the box. It's got a long battery life. But it's also cheaper. It's $100 cheaper in the US. It's only $299. So that was a huge piece of our non-negotiables. We wanted to hold on to the best features of the Quest 1 and get the price lower so more people could try VR. And it worked, obviously. We're doing well with this product. It's always out of stock. I know. You know, the funny thing is we haven't been able to keep it in stock since we started shipping it in the fall. And it's a good problem to have, but I really wish we could sell more. So we're working on it. Then we added something called the Link cable, the Oculus Link cable, which means all those people who were really hardcore gamers who are playing VR on their PCs could use this for those PC games. And now we're working on something called Air Link, which you don't even need a cable. So really exciting, and our non-negotiable for this was getting it to more people. And of course, the screen was better, 50% more pixels, etc. So there's a lot we included. The battery life of the controllers is like, something like, mine lasts something like 30 days, which was a huge achievement. So I gave you a brief overview of these 4 different headsets with very different design targets, very different customers in mind. And I explained what I meant by non-negotiables. So for the rest of the talk, I'm going to dive into some more details and targets for these devices. And basically, these are the things that you need to determine what the customer is going to experience up front. And then you go into the technology and figure out how to solve those problems, which is what we're going to do next. Before I do that, though, I'm going to give you, you said I was the only mechanical engineer here, so I'm going to give you a little background on how VR works so you understand the rest of the presentation. So now that we've defined our non-negotiables, what next? The truth is this part varies a lot depending on what decisions you've just made on your non-negotiables. And so I'm going to slip in this quick section on how VR works and where the technology is, again, so that the rest of my presentation makes some sense. So this is a slide that basically says, what does my human perceptual visual system do? Okay, obviously VR is not here yet, but I'm going to start with what do our eyes do for us? It's pretty amazing, actually, if you look at it. Obviously, there's no panel resolution. Right here, we don't have that with our eyes. Visual resolution, a lot of us not as many of us in this room maybe because we studied pretty hard, but most people have a 20/20 vision. Our field of view is actually 220 degrees, not even this way, so we can see tigers kind of creeping up on side of us. This is incredible, by the way. And our depth of focus is variable. So if I look at you, Ali, or I look at the back of the room, there's variable depth of focus. So these are some pretty intense design targets. And so we're going to now look at where VR is now. Where VR is now is Quest 2 has about 2K per eye, I would say. Visual resolution sometime around 2070 or 2090, something like that. Only 90 degrees field of view. And a depth of focus is fixed. Depends on the product at about 2 meters, something like that. So this gives you a sense of how far we are away from where we need to be. This is pretty bad, really. We have a long way to go before you're going to be immersed in VR and not know that you're in VR. But that's part of my job, is to try to get us there. Now, I'm going to talk about things next, which our research team is focused on. We have 2 divisions, really, at Facebook Reality Labs. We have my division, which is we're making products. And then we have a research division, which is doing all kinds of cool stuff and publishing, by the way, a lot of really cool stuff. And some of this is published, but they're not connected. So I'm going to talk about some things that are in research, but not necessarily in product. Hopefully will become in the product. So how VR works is pretty simple. You have a screen, like a cell phone screen, and you have 2 magnifying glasses in front of it. That's it. You either have a 2-part screen or a 1-part screen. And so to reach what our visual system is capable of, we need to take VR from where it is now to 3 times more visual resolution on each axis, 3 times the field of view, essentially, maybe a little bit less, and variable focus. This is just a quick slide on how we get the lenses as small as possible. These are just plano convex lenses. They're like magnifying glasses. But if you cut them in concentric circles, you can kind of smush them a little bit. I think that's the technical term for that, and make them a little bit smaller and lighter. So this is what VR does now. And then there's a couple different kinds of displays. I'm not going to go into them in detail, but basically you have LEDs and OLEDs, just like your TV at home. Same concept. And then something called pixel fill. This is important, because if you've ever used VR, you can see the space between the pixels, right? That's a screen door effect. And that means that you don't feel like you're really there. You notice it. Anything you notice is bad. So we're going to try to think about diffusers or bigger pixels or ways to increase that fill. All right, the last one and the hardest, I think it's the hardest because I'm the mechanical engineer and I'm not doing the video encoding. But the hardest thing I think is actually ergonomics. If you have a headset on, after a couple hours, you really notice, you know? And if you've had to do work in a headset, it's even worse, because work isn't fun. Like shooting zombies is fun. Work is not fun, so you notice even sooner in work. And so you've got a difference between where the load is, and you get some neck strain if you wear a headset for a long time. And this is just some calculations, obviously torque, force times distance. We're trying to get the weight of the headset down. That's all this is saying. And the weight distribution of the headset better. So this is a huge part of VR, which is my team's job. And luckily I work with some of the most intelligent folks in mechanical and electrical engineering that I've ever worked with, who are working on this problem every day back home. So that's basically the quick primer on how VR works. So we're going to go now into rule number 2. Start with the hardest problems first. Now my background at Apple is we made the first unibody MacBook Pros, you know, the ones, this was a little while ago, about over 10 years ago, where they were machined from a single block of aluminum. And then for the next 3 years, I worked on the MacBook Airs, which I think are great. I still like those products. I'm very proud of that, that our team did a good job with those. And so we had to do a lot of this. In order to make these products for the first time, you have to start with the thing that's going to break first, the thing that you don't even know if you're going to be able to do. And so basically this is kind of a funny slide, but all I'm trying to say is most of us follow the red curve. We say, okay, I kind of know, like, even if we're making a slide deck, right? Like you kind of start to type in and you change the fonts and you line everything up, and it's just like, that's the last thing you should be doing. You should be like, what is my presentation about, and then how do I want to build it? But we're just, as humans, kind of go to the easy stuff first. I am arguing we should follow the green curve with hard projects and 0 to 1 projects, which just mean, what's the hardest thing? You know, I'm going to do that here in the beginning. This is just a time curve and an effort curve. So like, I'm going to start with the hardest things I don't even know if it's going to work out, and try to prove those out first. And then hopefully, and this has never happened to me before, but hopefully in the future someday, it'll be easier and easier as the time of the product goes until I ship it. And of course, in hardware, we don't have the benefit of over-the-air fixes. Once we ship something, it's done. So that's kind of like you have 4 compiles, and you only get 1 each, and they're all 3 months apart. And then the last compile, you are done, and you have no more compiles and no more fixes. So that's the world that I'm in hardware. And so this is kind of my point here. So what are the hardest problems to solve in VR hardware? Well, in VR, we're solving for immersion. We want you to believe that you're about to get eaten by that dinosaur. And so each headset needs to respond pretty quickly to what you're doing in your content. And we want you to forget you're even wearing a headset, like I mentioned. So both the visual fidelity, which we covered a little bit, and the ergonomics have to be excellent. So in addition to processing power, which I don't have time to cover today, I think these are the hardest strands of the braid that makes up good VR. And so we'll start with optics. The optical stack, again, is the most important because partly because it's changing so fast, the technology is changing so fast, partly because this is the first thing you're going to notice in a new VR headset is how good are the optics. And again, we have the product side team and a research side team. So a lot of what I'm talking about is in the research side, not necessarily the product side. So let's get started here. Going back, this is what we're trying to do. Go from the bottom row to the top row. So where could VR go in the future? This graphic is a little complicated, but it's one of the best ways I've seen this explained, where you're like, where are we now and where do we want to go? This is a good graph for that. Visual fidelity, you can talk about it in a lot of different ways. One way is you take one single degree and 1 arc minute, and you tell me how much visual fidelity is in that 1 arc minute. And it's a function of display resolution and therefore visual immersion. So I'm going to show 2 things here. So essentially what you'll notice is this line right here, this 1, that's 2020. So that's the line we're trying to get to in all products, by the way. And then down here is legally blind. So we don't want to be here. We want to go this way. But you'll also notice focal length in millimeters. This is important too, because the further to the right you go here, the bigger the product is, right? The product has to get bigger. So the further your eye is from it. So you actually not only want to go up, you also want to go to the left because you want a VR headset that's small. Someday that's sexy, I hope. And so this is kind of why I'm showing this. And then pixels per inch is here. So where are we now? Actually, anybody here have a MacBook Pro? Okay, cool. So you've got a MacBook Pro right there. And it's only taking about 17 degrees of your vision. Okay, so not very much. And remember, we're at 90 degrees in VR, right? So you're already there. Boom. Easy. You are already right here. The MacBook Pro is on the 1 line. So you don't really see the the pixels, right? Okay. I remember when we used to, but in that you don't. But then the bad thing is you have to be all the way over here. So that's got to be pretty far away. We don't want headsets like kind of like this. So where are we? We're on the blue line right here. We're somewhere around 2070, 2090 in commercial VR. So how do we get this way? What are we going to be able to do to get somewhere like here, right? This is my job. Unfortunately, it's not easy. But luckily I have teams that work with us in display and optics that are very, very smart, very brilliant folks. So let's see. Let's go back 1. So basically one of the problems is LCDs don't get much better than where we're at now. So that's a problem. So we got about a 1,000 probably PPI on LCDs. After that, we're going to have to start getting creative and using different types of displays. And then along the top here, we're here in Fresnel land, which is magnifying glass land. We're going to have to start hopping into something called a pancake technology to get any further. You can kind of see we're right here. So we're about to graduate both in both axes in order to get better. And so this is how we're going to do it, we think. We're not sure, but I think this is what we're going to do. We're going to hop straight up the curve and get higher PPI LCDs to max that out. Every year, the LCDs get a little better. So we're going to first go here, and then we have to hop over to Pancake with that same display. And then hopefully, over time, get up here. 4K by 4K displays, which is what we'd want, don't even exist yet. Nobody can make them yet. Oh, and I misspoke. Your field of view is probably 40 degrees, not 17 degrees. Again, but it's retinal resolution. So the goal, again, is to climb up to this 1 Arcman. So that's kind of what we're trying to do in the future of VR and where we're coming from. Everything in the next section covers the future and research prototypes, not products we're working on in the consumer space. So this is kind of fun too. Right now, if you look tops down on a headset, this is one way. We talked about the other things. We haven't talked about focal length yet. My eyes can don't have fixed focus. My eyes can focus on a mountain or on this remote. VR can't. VR is fixed. And if you spent much time in VR, that can be fatiguing, right? So how do we fix that? Well, there's a few ways we could do it, but one of them could be that you add a ring of LEDs around each lens in VR, and then you pop a camera actually through a hot mirror. And what that camera is going to pick up, so this is a Fresnel lens, right? And this is the LCD. So this is a cross section from the top, and that's your eye. And this is the ring of LEDs around the lens. And this camera is picking up what we call glints on your eye. And based on that, we can tell where you're looking, which is important. Because if you're looking at an LCD, you want to know, in order to get the focal length right, you need to know how far something is away that you're looking at. So are you looking close up or far away? We actually need to know X, Y, where you're looking to figure that out. And then you could do, this is a prototype, this has been published, something like this, where if you look closely, you can see these are actually moving. You could actually have, and because it's magnified, they don't have to move too far, luckily. But you could have, like in this prototype, you could actually move the lenses based on where you're looking. So this is one way we could maybe fix this in the future and give you a movable focal length. The last one's a big one, is ergonomics. This one's tough because everything else affects it, and it's not always easy to fix it once you have a design. If it's bad ergonomics, it's hard to go back. So it's important from the beginning. Now, this is a magnifying glass, essentially, and a LCD. This is a classic VR system. And you notice this distance actually defines the depth of the headset, so how big the headset is. So it's really, really important. And this is a pancake lens, which is really cool. You can see it's got 2 elements. And all that's happening is the light is bouncing around inside the lens. And so all this distance that it has to go out here is now happening inside the lens. So that means the display can get this much closer to your eye, which means the product can get this much smaller. So it's pretty exciting technology. And if you follow the red dot, every time it goes through a quarter wave plate, a polarizer, it turns a quarter. So the light comes in, turns, and then gets stuck, can't get through, turns again. So I'll do it one more time. You can see pops back and forth. And so this allows us, it's much harder to make. You know, the research is telling us it's going to be very tough to make these, but it's going to make the headset a lot smaller and a lot sexier, which is really fun. The last big one is sensing. This is how do I know, how do I feel immersed? And when I'm in this room and I look around, my perception changes right away. If you turn your head, what you see changes. And that's what we need to do in VR. Let's see. With the Oculus Quest, we did make 6 degrees of freedom mobile by creating that inside-out tracking architecture I talked about with the introduction of these inside-out sensors. We also added an accelerometer and a gyroscope to the headset, so we have a second source relative movement data. And we use IR LEDs in the new touch controller, but we flipped them so the headset could see them. And we also added sensors in the controller to track minute acceleration and positional changes. Also, we have something called Oculus Insight, which is really cool. Hopefully it plays. Didn't play. Bummer. Well, this guy's moving around, and what happens is Oculus Insight is software that uses these onboard sensors to automatically build a map of the physical space, which actually stays on the device. It doesn't leave the device. And what you'll notice is it finds corners and edges, and it remembers them. So that then it only needs a simple map to know where you are in that room. So every time you pick up the headset again, it will remember that local data will tell it, oh, you're in this room, and you won't have to calibrate it again. These sensors use machine learning to filter the environment and create a dynamic point cloud. And at Oculus Connect 6, which I think was last year, I'm getting them mixed up. I think it was last year, we announced that hand tracking was coming to Quest, which is really cool because in VR now you don't even need controllers to navigate basic menus. You can use your hands. And so we were able to use those inside-out sensors now on the headset. Those sensors meant to track the headset, now they can track your hands too. So you could interact more naturally in VR, or there would be experiences you wouldn't need controllers for, which is very fun. So now we've defined our non-negotiables, and we've worked on figuring out the hardest parts of the hardest problems, the overall optical and sensing architecture. So how do we build the rest of the headset? The truth is, this part depends a lot on the decisions you just made, because the distance between your lenses and the LCD defined the minimum size of your headset and therefore ergonomics. You've layered in sensing architecture to placing those sensors strategically to keep the overall headset as small as possible. And so next, you add in layers as you go. So I think about this as a braid. And the first few pieces of the braid are the hardest part, and then you add in more layers. There's a lot of things that I'm not going to talk about: silicon, material science, graphics, to name a few. But haptics is really important. Haptics is actually kind of incredible because it works like all kind of perceptual sensing pretty unconsciously. You don't even know it's working. So the phenomenon is that your brain fills in the gaps between what your senses are telling it. And that's largely automatic and unconscious. So haptics is this very magical arena, which we found out actually in Toybox when we made the first controllers. We sometimes just need the suggestion of movement if it correlates with what's happening in real life. For example, if your hand in VR touches something, we can just buzz the controller and your mind knows that your hand has touched something. It doesn't have to be the perfect haptics. So that's really good. I'm going to speed up a little bit through this. But basically, haptics is sound you can feel lower than 20 hertz. So anybody who's heard really heavy bass, that's haptics, if it's vibrating you, essentially. There's all kinds of different haptics. It's not just one thing. You have resonance, skin vibration. You could have edge detection. Actually, we're very good at that. Naturally, temperature, force, and weight, shape, or texture. And then we also have a really, really complex sensing architecture in our skin. And we want to take advantage of this, especially in our hands. We've evolved over millions of years to be really, really good at this. And our response to these things is actually different in time. So some of our responses are slow, like shape or skin stretch, and some of it's fast, like vibrations. And so we love vibrations for that reason, and we've got different ways that we can do vibrations in controllers or in the headset to give that perceptual add-on. All right, the last rule is rule 4, which is iterate like crazy. And most of this talk has been focused on headsets, but controllers are incredibly complex because we all have different hand shapes and sizes. And we wanted something in VR that was natural. And there were no VR controllers yet when we developed the Touch. So I'm going to talk a little bit about the Touch, which was our 0 to 1 controller. The controllers we've had since then are based on that design. And this is how you get from good to great in any design for customers. It applies particularly well here. So with the first Oculus Touch, our non-negotiable was hand presence. When you're in VR, you just grab things or interact with things naturally. That's what we wanted in VR. And so when we were first thinking about input, we made a bunch of really ugly prototypes. And you'll see what I mean by that. We were only focused on the hardest problem first. We didn't care about what it looked like. We didn't make a sexy thing. I don't know if you've ever done this, but sometimes you make something really pretty and you fall in love with it, and it's hard to keep going. So this is why ugly prototypes are great. We wanted to figure out the hardest parts, which was, what are the ergonomics like? Where are the buttons and actuators, and how can you track it? Those were what we wanted to do first. And nobody had made VR controllers ever before, so this was the Wild West. We finally started to iterate enough to get an idea of the handle shape we liked. Then we started thinking about tracking. How could we track the movement of these controllers through space? And what was getting in the way of those natural hand movements? In the end, we wanted you to be able to open your hand. After we determined the sensing architecture and placed the IR LEDs, we got into more detailed design, the button placement, trigger and grip actuators, and we made sure that all kinds of people with different hand sizes could use the controllers. So we ended up with a slightly tapered handle, so you could choke up or down on the design. Finally, we layered in detail design, features and finishing touches, and brought in natural movement VR controllers to light. The crazy thing is we actually got to here in just the ergonomics and had a totally different set of prototypes to do the electrical engineering, actuation, PCBs, and all of that. And it's only when we got to like basically one step before this that we started to combine them together, which kind of goes to my second rule. So today I've talked about 4 key development rules for doing things for the first time. And then I talked about how they apply to VR. And a lot of people know these rules. These are not my rules. They're really the art of product development. But most people don't actually follow them. And you have to apply them rigorously from the very beginning. And no matter what we do, we never forget the whole point of all this work and all this engineering and why we do all of this in VR. We do all this work to create immersion. If we do our job right in VR, in hardware, optics, and sensing, and someday in video streaming, in sick stuff, all these parts and pieces just disappear. And people come face to face with the content and experiences that they care about most. I actually took a 360 camera shot. It doesn't look very steep, but it was very steep. This is Lesotho on a motorcycle tour. And I'm so excited because when I pop a headset on, I can relive this being at the top of this kind of cliff and feel fully immersed and almost like vertigo. So this is something that I really enjoy revisiting. And so I just wanted to thank you so much, Ali and MMSys, for having me. And I hope we'll chat soon after this.